Next up will be Arkadeep Kumar from Mechanical Engineering, speaking on novel abrasives for cheaper solar cells.
The hurricanes near us or the wildfire in California, both have become worse with unpredicted weather patterns, rising air and water temperatures, rising global pollution levels. All are challenges for the future of our planet and every one of us. So what can we do? Reducing carbon emissions by using cleaner energy sources like solar cells would help. One of the obstacles of widespread adoption of solar cells is the high cost of the material which form the fundamental building blocks of solar cells we see on our rooftops, which are the silicon wafers. These silicon wafers are manufactured by a wire sawing process where silicon brick or ingot is going down at a slow speed. Tiny abrasive particles attached to the wire is going at high speed from one roller to another. This relative motion between the abrasive and the silicon brick slices this into very thin wafers, 200 micrometers in thickness. Human hair is 50 to 100 micrometers in thickness. Material cost can be reduced by making even thinner silicon wafers. However, they would break easily unless we have higher mechanical strength of the wafers. Now, the mechanical strength of the wafers depend on the micro cracks created in these wafers by the abrasives during the cutting process. In our research, we found the shape of the abrasives are critically important in affecting the size and number of cracks in these wafers. Currently used diamond abrasives in industry are irregular in shape and size. Hence, it's difficult to control the micro cracks. The key thing which is missing is engineered shaped abrasives, which would reduce the cracks. Hence, in our research, we developed and designed spherical tungsten carbide abrasives, which reduce the number and size of micro cracks in lab scale experiments, which simulated the slicing process. Using the spherical tungsten carbide abrasives, we obtained more than 50% reduction in size of cracks and fewer overall micro cracks, which is expected to increase the mechanical strength of these wafers. Using these spherical abrasives, we can obtain wafers which are higher in mechanical strength and also thinner, reducing the cost of solar cells and encouraging the use of clean, eco-friendly solar energy. Thank you.